Okay, so for number 1, we're going to find the true speed and direction of the jet in example 3 if the pilot heads in north 45 degrees west. So if you do north 45 degrees west, okay, I drew my little picture here for north 45 degrees west. So your theta value would have to be 90 plus 45 degrees, which would be 135 degrees. That's going to be your theta. Okay, and if we're trying to figure out where the pilot heads the plane, eventually what we're going to do is we are going to find the tangent of theta. But in order to do that, we have to go ahead and recalculate the jet vector, okay, using the 135. Now, the only thing that changed there was the jet. So the wind is not going to change. It's going to be the same vector as we had in example 3. And then, of course, to find the true velocity, we're going to add the jet and the wind together. So our new jet plus our new wind, we're going to add the 2 horizontal components, add the 2 vertical components. And then to get our true speed, we're going to find the magnitude. So it should be 781.05 miles per hour. How many of you got that one correct? Oh, yeah, put it up a little bit. Yep, so 781.05 miles per hour. Okay. Do you guys have questions for me on that part? Okay, now the direction. So this one might have been a little bit challenging for you. What you're going to do is you're going to do the tangent of theta equals your b over a, so the vertical component over the horizontal component, and that's of the true velocity vector. Okay, so my true velocity vector is going to help me set up my direction here. And I get theta is negative 48.9. So here was the tricky part. First, if it's negative 48.9, this is going to be in what quadrant? Okay, in quadrant 4. If we look at my original picture, right, the jet is in what quadrant? Quadrant 2. So what I want to do is I want to find this angle in quadrant 2. So really the theta value that I'm finding is from here to here, which I can find by just, adding 180, okay, because they're going to be 180 degrees from each other. Okay, so this is going to be your theta, your direction. Okay, so then when you do that, you get 131.1 degrees. So did some of you write the 131.1 degrees? Or probably a lot of you wrote the negative 48.9, right? Oh, okay, good. So if you got to the 131.1, that's great. So this is what I just talked about in the bell work, right? You wouldn't want to say 131.1 degrees north of east because really the plane is heading in this direction, which is northwest, right? This would be 131.1 north of east, which doesn't make sense when you're going northwest. So what I did is I drew a picture for you that this is the 131.1 degrees. And then to get the correct bearings, you can just take the 131.1 and subtract 90. And then your final answer would be 41.1. You could either say west of north. You could say north 41.1 degrees west. You could say west 48.9 degrees north. Or you could say 48.9 degrees north of west. So all of those answers would be acceptable. Ben and then Courtney, if you have a question.
Can you also use head-to-toe vectors to solve that problem?
Yep. And if you're in physics, you're welcome to do that. So did you get this one of these 4 answers?
No, but I was just asking.
Oh, okay. Yes. Yeah. If you are in physics and you're more comfortable with the head-to-tail method, that's perfectly fine. Just as long as you can write your final answer in terms of the bearings.
Can we do the whole thing? Physics mode?
Like your picture? Yeah.
No, like the whole thing, like even one, like questions like what? Questions can, like one, and like all questions can we just do?
I'm going to say yes and no because yes, you can do all the calculations that way, but when you write out your answer, it'll have to be in component form.
Okay.
So as long as your final answer and your work are all presented, then you should be good. Okay, and I can check yours too if you're unsure about something. Oh, yeah. Yep.
Sorry, I got to the 131 and then I did 180 minus that 131, so I got the 48.9 or whatever.
Okay, good.
And that the angle's on the left side though, so would you rather us find the angle between the 90 degrees and the left?
Nope.
Does it matter?
Nope, doesn't matter. So did you say 48.9 north of west?
I said
West.
north.
Okay, yep. So did you say west of north or west 48.9 degrees
I
north?
said west of north, so I got that part wrong.
Okay, yeah. So either just change it to north of west or you could have this. And that's still 100% correct.
Okay, so it doesn't matter what angle we find.
Right. So it doesn't matter what angle you find as long as it's in that quadrant.
Thank you.
You're welcome. Okay, so now let's look at number 2. So number 2 says, in what direction should the pilot in example 3 head the plane for the true course to be due north? So this is going to be a little bit different. Remember that the true course, that's going to be the addition vector, the vector v plus the jet plus the wind. So what I did is I drew a new picture. So my jet was right here. Okay, so this is the same picture as in example 3. I still have the wind with the 30 degrees, but then I made this line dashed because that's where we're going to want to head, is we're going to want to head north. Okay, so if you guys need to draw that picture, please feel free. Do you guys have questions about the picture? Okay, so the true course we want due north, our jet and our wind are from example 3. So just a couple of things to keep in mind that I wrote down for you. The wind is going to stay the same. Okay, the wind is blowing still with the magnitude for that one. What was it? The magnitude for the wind? Was it 55 or 38? Okay, 55. So the wind's going to stay the same. It's the airplane that's going to head in a different direction. So your theta value is going to change. Okay, so your wind is going to be the same from example 3. And because our theta is changing, we actually are trying to find this value of theta. So this is what's going to be a little different from the examples that we did yesterday. So we know what the magnitude of the jet is. It's the 765 miles per hour. But we're trying to figure out where he should head the plane. So we're trying to figure out the theta value for the jet. So we don't know what that is. Okay, that's what we're trying to find. So what we can do is we can still find our vector by adding those together. So if I add the 27.5 to the 765 cosine of theta, I'm going to have this expression.
Isn't it sine of theta for the second one?
Oh, yeah, thank you. And for the second one, you are going to have sine of theta. Okay, and then the next thing we're going to do is apply a little bit of reasoning. Okay, so if you want to head your plane so that it's going north, what kind of forces would make the plane not go north? So if you want to fly straight, right? If wind is coming at you from the west, or if wind is coming at you from the east, isn't that going to push you off of your course?
Yeah.
Okay, so if it's coming from the east, it'll push you this way. If it's coming from the west, it's going to push you the other way. So if we're looking at this, east to west is going to be the horizontal component. And we don't want any of those forces acting on the plane because it's going to sway it in a different direction. So what you want is you want your horizontal component to be 0. Okay, so that might be something good to write down. So you want your horizontal component to be 0 if you want to head due north. Okay, because then there'd be no horizontal force acting on the plane. And And another way that you can think about that, which is the picture I drew here, if you want to go true north, the angle of theta of the plane going true north, you'd want it to be 90 degrees, correct? That would be north. And what is the cosine of 90 degrees? It's going to be 0. Okay, so you want the horizontal component to be 0. So what we can do is we can take this expression and we can set it equal to 0 and we can solve. Okay, so if I take the 27.5 plus the 765 cosine of theta, and I set that equal to 0, okay, then I can solve for theta. So I would subtract 27.5 from both sides. I would divide by 765, and then how do I find theta? Yeah, take the inverse cosine. So will you guys go ahead and do that for me right now? So you're going to find the inverse cosine of negative 27.5 over 765. Okay, yep, Ben, what'd you get?
92.1.
Okay, so the 92.1 degrees for theta is representing the north of east. Okay, so if you were to draw a picture, right, your 92.1 is going to be really, really close to this. Here, this is going to be the 2.1 degrees. Now, would I say 92.1 north of east, or should I say something else? I should say something else because really, look at the quadrant. If it's in quadrant 2, it's going to be going towards the northwest. So you can choose how you want to say that. You can either say north 2.1 degrees west, or you could say 2.1 degrees west of north. Or if you subtracted it from 180, you could use that as well.
Wait, Miss Whipple, why do you set it equal to 0 and not 90 degrees?
Because what you want to be the 90 is the theta. The whole component is what you want to be 0. So you want this horizontal component to be 0 so that you're going straight north. Because if this is your vector, right, if your vector straight up and down, there's no horizontal component. If your vector wasn't straight up and down, let's say this was your vector. This would be your horizontal component, this would be your vertical. If your vector is straight up and down, you aren't going to have a horizontal component, you'll just have a vertical component. Okay. All right, and then we're going to look at the rest of them too.